Have you ever stopped to wonder what's really going on when you connect to Wi-Fi? I'm not talking about the websites you see, but the invisible, foundational plumbing underneath it all. Well, today, we're going to pull back the curtain on the architecture that powers our entire digital world, from your little home network all the way up to the massive cloud. So let's get right into it.
All right, so let me start with a little puzzle for you. What on earth does your physical home address have in common with your laptop? It sounds kind of weird, right? But the answer is surprisingly simple, and it's actually the key to understanding how billions of devices can communicate, almost flawlessly across the entire globe. Well, the answer is they both need a unique address. It's that simple. Just think about it. A mail carrier needs your street and your house number to deliver a package. In the exact same way, the internet needs a digital address to send data directly to your specific device and not your neighbor's.
Let's bring this closer to home. Think about your own Wi-Fi. You've probably got phones, laptops, maybe a smart TV, all connected to that same network. Now, what if you wanted to block your kid's tablet from the internet after bedtime, right? To single out just that one device, it absolutely needs a unique identifier. Otherwise, you'd have to shut down the internet for the whole house.
And that unique identifier? It has a name. It's called an IP, or Internet Protocol Address. This is the fundamental digital address for every single device online. Seriously, you could think of it like a unique fingerprint that makes sure the data meant for your laptop gets to your laptop and absolutely nowhere else.
We can actually break down an IP address, just like we would a physical one. The first part, something like 172.16, that's kind of like the street name. It identifies the bigger network you're on. Then the numbers that follow, like 0.3 and 0.4, they act more like the house number, getting more and more specific, until they pinpoint one exact device.
And the most common format for this, which is called IPv4, is really just 4 numbers separated by dots. That's it. Each of those numbers can be anything from 0 all the way up to 255. It's this simple, standardized structure that gives us millions of unique addresses, creating this universal system that the entire internet can understand.
Okay, so every device has an address. We got that. But what happens when you just throw all those devices onto one big, open network? Well, you create a huge security problem that can only be solved by, you guessed it, building some digital walls.
And this brings up a massive security issue. Just imagine an office where every single computer, from the one at the front desk to the one in the CEO's office, is connected to the exact same open Wi-Fi network. I mean, what could possibly go wrong?
A lot, it turns out. A whole lot. If a hacker gets into just one employee's laptop, maybe through a shady link in an email, they can now potentially see and access every other device on that flat network. We're talking servers with sensitive financial data, payroll info, everything. It is a massive, massive vulnerability.
So the solution is to build those walls. And in the world of networking, we call this a subnet or a subnetwork. It's basically a way to take one large network and logically chop it up into smaller, completely isolated zones. And the key word there is isolated. So for example, you can create one subnet for Open Guest Wi-Fi, which just gives visitors some basic internet access. And then you create a completely separate walled-off subnet for the Secure Finance Network. So now, even if that guest network gets compromised, the digital wall makes it impossible for attackers to ever reach that sensitive finance data. It's a simple idea, but it's an incredibly powerful security strategy.
Now, here's the really cool part. These fundamental ideas, IP addresses and subnets, they're the exact same principles used to build the modern cloud. Let's take a look at how they let you carve out your own private piece of that cloud.
I want you to imagine a public cloud provider, like Amazon Web Services or AWS, as a vast open plot of land. I mean, it's huge. Anyone can come and build on it. And while that's super powerful and convenient, you wouldn't build your private company headquarters right out in the open for the whole world to see, would you? Of course not. And this right here is where the Virtual Private Cloud, or VPC, comes into play. It's like building your own private, gated community on that huge plot of public land. It's your own logically isolated, totally secure slice of the public cloud that you, and only you, completely control.
Okay, so let's put all the pieces together. The VPC is the outer wall, right? That's your gated community. Then, inside, you use subnets to create different neighborhoods, maybe one for your public websites and another for your private databases. And finally, inside each neighborhood, every single server gets its own unique IP address, its house number. See? It's a layered system, from the big community gate all the way down to the individual front door.
But building the community is only half the battle. Now you have to actually secure it. And let me tell you, one layer of security is never, ever enough.
Just think about it for a second. A real gated community has a main gatehouse to control who comes into the neighborhood, right? But once you're inside, every single house still has its own lock on the front door for that extra layer of protection. Well, cloud security works the exact same way.
And this distinction is so important. At the subnet level, the neighborhood level, you have what's called a network ACL. Think of this as the main gatehouse. It controls traffic for the entire area. It's your first line of defense. But then, for each individual server or house, you have something called a security group. This is the lock on the front door, controlling traffic for that one specific server. It's your last line of defense. You absolutely need both to have a truly secure setup.
So let's bring it all home. We've gone from a single, simple address to a fully secured, private community in the cloud. We've literally built the very foundation of your internet experience. We started with the humble IP address. That was our brick. Then we used those bricks to build walls, our subnets. Those walls then formed a secure building, our VPC. And finally, we put the locks on the gates and doors with NACLs and security groups. From a single brick to a secure fortress. So the next time you stream a movie, or check your bank account, or connect to your office network, just remember this invisible architecture that's working tirelessly underneath it all. These addresses and walls and locks, they are what make our digital world possible. It really makes you wonder, as our world gets more and more connected, what will the next digital wall need to protect?